Meet Jay. Jay has always been the life of the party. One afternoon, Jay and his friends headed over to the beach. After they were in the water for about 20 minutes, Jay's friends suddenly ran out of the water laughing and shrieking in disgust. It seems that Jay urinated in the water at the beach. How disgusting. After teasing Jay and talking for a while, we began to think, if rainwater comes from the evaporated water from the earth, then would Jay's urine be included as a part of the precipitation? To explore this question, we talked to a few people on the street.
You know, like if you throw like one of those 6-pack plastic things into the ocean, it just like stays together and it kind of disappears somewhere. You don't see it anymore. Clears your conscience. So probably what happens is like just like that, the urine kind of stays together because it's not with the water, and then it goes through and it comes up with the rest of the water, however it gets into the clouds, and then comes down also together in the same area. So maybe like some areas have more urine concentration than other areas.
Well, I believe that water and a certain set of other chemicals evaporate. I don't know exactly what's in urine, but I know the water in urine would evaporate and certain other parts of urine would not, so I wouldn't say urine as a whole.
Does the urine come back as rain? Of course it comes back as rain. I mean, I was just out yesterday and it was raining and you could almost taste it. It was disgusting. I had to get an umbrella. You just had to watch out when it's raining, is all I have to say.
No, the rain will not include the urine from Jay, because since the water evaporates and when it goes into the clouds, evaporation is a form of heat towards the water. Heat normally removes it, like bacteria from things, so therefore all the bacteria in the water that is the urine will be removed when it evaporates, and then when it comes back down it's pure again.
So the urine actually won't evaporate and won't go up in the rainwater, because actually no ocean water evaporates. Actually ocean water isn't part of the water cycle. And the reason why is because the ocean water is so compact and condensed together, kind of like when you have snow in a group, it's not going to melt if it's condensed together and packed together. You've got a large group of snow. But if you take snow separately and put it in a small container, then it can melt. The rest of the snow isn't there to keep it warm, to keep it cold. So, like the ocean water, and anything in the ocean water, it's not going to evaporate because there's so much other water there keeping it moving and stopping it from actually being heated and condensed and to go up in the water cycle.
There are 4 critical ideas that we need to understand to explain Jay's situation: condensation, evaporation, transpiration, and precipitation. Let's start with condensation. In physics, the change of a substance from a gaseous vapor to a liquid state is what scientists call condensation. Condensation is the reverse of vaporization or evaporation. That's when a substance changes from a liquid to a gas. It can be brought about by cooling, as in the case of distillation, or an increase in the pressure resulting from a decrease in volume. Certain natural phenomena, such as dew, fog, mist, and clouds, are the result of condensation of water vapor in the atmosphere. The formation of dew illustrates well the fundamental principles involved in such phenomena. The explanation of condensation can be found in kinetic molecular theory of gases. As heat is removed from a gas, the molecules move more slowly. As a result, the intermolecular forces are strong enough to pull the molecules together to form droplets of liquid. Similarly, reducing the volume of the gas reduces the average distance between the molecules and thus favors intermolecular forces tending to pull them together. This is condensation. Evaporation is the name given to the process in which liquid is converted into a gaseous state. Suppose the that you spill a teaspoon of water on the kitchen table. If you come back a few hours later, the water will have evaporated. It changed from its liquid phase to its water vapor phase. This is known as evaporation. At the molecular level, evaporation occurs because all the molecules of water are experiencing random molecular motion. Consider hydrogen and oxygen molecules that make up the teaspoon of water. Those are in random kinetic motion, and sometimes they'll collide with each other. And with these collisions, some of the molecules gain just enough energy to change from their liquid phase back to their gaseous phase. Eventually, they may be able to move fast enough where all of the water molecules transition from the gaseous phase to the liquid phase. This is known as evaporation. Precipitation. Clouds contain gaseous water vapor, which are small drops of condensed water. These droplets are way too small to fall as precipitation, but they're just large enough to be visible in the form of a cloud. Water is continually changing states through evaporation and condensing in the sky. If you look closely at a cloud, you can see some parts of the clouds evaporating while other molecules in the cloud are condensing. Most of the condensed water in the clouds does not fall as precipitation because their fall speed is not large enough to overcome the updrafts which support the cloud in the air. For precipitation to happen, first, tiny water droplets must condense on even tinier particles of dust, salt, or smoke particles. These will act as the nucleus for the water molecules to condense. Water droplets may grow as a result of additional condensation of water vapor when the particles then begin to collide. If enough collisions occur to produce a droplet of water, it will fall because the velocity of that water droplet will exceed the updraft speed of the air. Then, it will fall out of the cloud to form precipitation. This is not a trivial task, since millions of cloud droplets are required to produce a single raindrop. This is the process of precipitation.
Baby, can I watch you groove? Won't you turn around and look at me?
The hydrological cycle is the journey molecules of water take as they circulate from land and the sky and back again. Photons from the sun's heat provides energy to evaporate water molecules from the Earth's surface, for example, oceans and lakes. Plants also lose water in the air in a process called transpiration. The water vapor eventually condenses, forming tiny droplets in the clouds. When the clouds meet with cool air over land, precipitation in the form of rain, sleet, or snow is triggered, and water returns to the land. Some of the precipitation soaks into the ground. Some of the underground water is trapped between rocks or clay layers. This is called groundwater. But most of the water flows downhill as runoff, eventually returning back to the slightly salty water of the sea. When we watch the weather report, we are watching a simple report of the hydrological cycle. The reporter tracks the movement of hot air masses and cold air masses. The weather reporter knows that when these two types of air masses intersect, the immediate product will be an intense condensation process and ultimately the precipitation of water molecules. So as we watch the weather report, we're actually documenting segments of the water cycle. Although the reporter does not provide reports of evaporation, when the report is of sunny days, they are essentially offering a report of the evaporation index. So now let's return to the scene of the crime. So given that what we've learned about the hydrological cycle, what can we say about Jay and the case of urinating in the beach? Would the rain include his urine? That's a question that only you can answer.